This is a worked example on how to write all solutions to a circular equation. So here we have sine of theta equal to 7 over 11. And this is a really awkward equation to solve because 7 over 11 is just nowhere to be found on the unit circle. Not only does it not have pi involved, but, well, I don't know why I said not only. That's just it. I mean, there's no pi involved. There's really no good way to approximate this guy. Um, and so what we have to do instead is take advantage of the arcsine function in order to approximate a value. Now, this sort of gets into the same situation with logarithms where our final answer is going to look completely ridiculous. But the whole idea is that it is an answer you could plug into a computer and it would be able to solve for you. So we're solving directly for theta, kind of just not caring how ugly it looks to actually get there. But we're going to do the following method. So first I want to solve directly for theta. This step is pretty easy. Let's just take the arcsine on both sides. So we take arcsine of sine of theta, and I have to do to one side what I do to the other, so I take the arcsine of 7 over 11. These functions cancel, and so now we have our value of theta. Theta is arcsine of 7 over 11. Now again, I don't even know how to compute that, but I'm going to leave it in that form, and that's just going to be my answer for theta. Right, I could plug that into a computer, I could get a value, but all I'm looking for here is a closed value of theta. But then we want to keep two things in mind. First thing we need to keep in mind is that sine is a output of a y value. So let's just say that 7 over 11 is like right here or something, right? That's an xy output value. But the reference angle on both sides, that's going to be negative x, is the exact same. So I could just as easily have an output value on the other side of the circle. So we actually need to take care of two values. Here's our arcsine value, and over here we want to take pi minus the value to take care of the other example. This is pretty trig function dependent, so if I was dealing with cosine, you would want to think of this in terms of x values. If this was tangent, you would kind of reflect it across the circle. Either way, this offers us a second solution for theta, which is pi minus arcsine of theta. Or not theta, 7 over 11. Okay. Now, the second thing we need to keep in mind is that all angles coterminal to both of these guys are also valid solutions. So again, we've looked at this sort of notation before, but I have to say two things. So I have theta equals arcsine of 7 over 11, and this is going to be in any configuration of plus 2 pi times k. And same thing over here. Arcsine 7 over 11 plus 2 pi times k. And in these cases, I want to specify that k is an integer. And so these solutions look pretty horrendous, but this is, in fact, the valid solutions to theta. So again, solving directly for theta, not the hardest thing in the world, but you do want to make sure you're taking care of those reference angles, taking care of those coterminal angles. But that gets you a complete value of theta, and that satisfies all solutions to this equation.